All right, so here we go, finding real solutions to polynomial equations, part 2. So I just have some more examples to throw at you in this one. So the first one's a little bit bigger. I've jumped from x to the 4th to x to the 5th. So what I have for you is 2x to the 5th minus 9x to the 4th minus 10x cubed plus 78x squared minus 28x minus 105 equals 0. And now that we've been through part 1 already, I really want you to be a little more interactive. Well, as interactive as you can be in a video, but I want you to participate and write some stuff down. So take a moment, look at this polynomial, and just see if you can see how many sign changes there are, so we can start looking at how many positive, how many negative do we expect. And if you have to at any time, you can always pause me, just stop the video and come back and see how you did later. So what I see here, and I really did plug my mouse in because I think I took it apart. So hold on. Let's put that in there. So let's look right here at how many sign changes I have. So here's 1. Negative, negative, positive, there's 2. Positive, negative, there's 3. So I have 3. This says I have 3 positive sign changes, so I have 3 or 1 positive solutions. How many negatives do we have? So before you look at what I did for the negatives, plug negative x in for those x's in the equation and see if you can figure out how many times we see a sign change there. Okay, I hope you paused me and you tried it. If not, do that. So you can see, again, through in parentheses around that negative x, and just really careful at that to see I have negative 2x to the 5th minus 9x to the 4th plus 10x cubed plus 78x squared plus 28x minus 105. So this was negative, negative. There's a positive. That's 1. Then it says positive, 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 negative. There's 2. So 2 says I have 2 or 0. All right. So let's go on, and this is where it got a little bit longer, and the complexity here is really this 105 that's down here at the end. So I listed all the roots there, so any factor I had. So I have plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 7, plus or minus 15, plus or minus 35, plus or minus 105. The q is just 2, so I have 1 and 2 as my factors. So you can see I have this long list of possible factors here. I took all of the 1, 3, 5, 7, 15, 35, and 105, and then divided them by 2 as well. So I have quite a lot of numbers that I need to plug in. And again, since we've done this before, I'm hoping that you're getting better at putting these into your calculator. You can see you wouldn't want to do this by hand. It would just take forever. But after you do it, and again, pause me, try those numbers, see which ones you can find, and then when you come back, click over and you'll see what I got. All right, so I got these 3. I got negative 1, I got 3, and I got 5 halves. So these are my possible solutions that are rational, but I still should have some more. This is only 3 solutions, and I expect there to be 5. So I'm going to use synthetic division again, and it's going to take us a while to get through, so just hold on for that. All right, so here's a cleaned page, and again, I like to write in black when we're doing this because I think it's easier to see. So I'm going to start from those choices at negative 1 because I think it's the easiest of them. So I'm going to write down here, put that in a box. 2x to the 5th minus 9x to the 4th minus 10 was my x cubed, 78x squared minus 28x, and then finally that negative 105. Okay, there's my big line. Remember, the first term comes down and then I multiply. So this is negative 2, which gives me negative 11. This negative negative will become a positive 11, so I just get 1. Negative 1 times 1 gives me negative 1, so this turns out to be 77. I multiply by 1, now it's negative 77. When I add that to negative 28, there's no surprise, I get negative 105, so that when I multiply it by 1, there's 105, which gives me that 0 we wanted. All right, so we just went from x to the 5th down to x to the 4th, and if you go back to the solutions that we had, and I may have to just go back to the slide so I can show you, the next one I see is 3, so let's go ahead with that 3 and put it in a box. Draw a line underneath and drop that first term down. Okay, 3 times 2 is 6, so this gives me negative 5. I multiply 3 times negative 5, which gives me negative 15. I add that, I get negative 14. If you get worried about multiplying these, then grab your calculator. So you can go negative 14 times 3. That gives you negative 42. And then you can subtract. So there's 5 and there's 3. So there's 35. 3 times 35, 105. That's good because that gives me a 0. Okay, so this was 5, this is 4, this is power 3 now. I still have one solution left that we found, which was 5/2. So let's put that over here. And I like that this time I'm going to use it as a fraction because on the first part I did it as a decimal. So remember, bring that 2 down. 2 times 5/2 is 5. That gives me 0. 0 times 5/2 is still 0. It gives me negative 14. And when you're multiplying by fraction, I go 2 goes into 14. That gives me 7. Negative 7 times 5 is negative 35. Oh, that's a really bad 3, but we know what it's supposed to be. And there's a 0. All right, 5, 4, 3, 2. This says I have 2x squared, 0x minus 14 equals 0. All right, next slide. That way we can start over. So this 2x squared minus 14 is going to give me my remaining two solutions. You could take the 2 out if you want, or you can choose not to, but I get x squared minus 7 is 0. So this says x squared is 7. X is plus or minus the square root of 7. Okay. So I'm going to show you another thing we haven't done yet. You could write them as a solution set. So I had negative 1, I had positive 3, I had 2.5 or 5/2, whichever way you want to write it, and then plus the square root of 7, and then minus the square root of 7. Oops, dropped it there. All right, so that shows you you have 5 solutions to the power 5 equation. All right, so another example in here, example 2, a little bit different. I have x to the 4th minus 14x squared plus 45 is 0. And what I want you to see here is that you don't always have to use Descartes' rule of sign and the rational root theorem. Sometimes we get lucky and we have something we know how to factor. And what I really want to point out here is, see how this only has 3 things, x to the 4th, 14x squared, and 45? It feels very much like a quadratic. Even though it's not, quadratic is power 2, this one's power 4, but it still has that same feel because it has 3 terms. And it goes x to the 4th to x squared, so those have that relationship. So what I want to see here is 45. If I factored it into negative 9 times 5, that would give me negative 14. So I'm going about it the same way I do a quadratic. Look for factors with the last term that give me the middle term coefficient. So let's do that. X to the 4th, when I split it, becomes x squared and x squared, which is good because the x squared becomes that middle term. So I have x squared minus 9 and x squared minus 5 equals 0. Well, I can split that, right? And there I say x squared minus 9 would give me plus or minus 3 as answers, and x squared minus 5 would give me plus or minus the square root of 5 as answers. So just that you had a feel of my first example much bigger, and this last example, even though it's power 4 solutions, much easier to answer.